Hi, this video is on Chapter 14 test review. There's only 3 sections in Chapter 14 that were covered. So if you look at these problems that we do, um, that I'm about to do, and you're able to do them, then I think you'll do fine on the test. So let's take a look at the first one. Find the restrictions for the value of x. So anytime you're looking for restrictions and we're dealing with a fraction, dealing with fractions, the only restriction we know we have is the bottom of the fraction cannot equal 0. So, the bottom cannot equal 0. We say cannot equal 0 that way. So all we're looking for, we don't care about the top. We just say the bottom, 4x plus 2, it cannot equal 0. Because if it's the bottom, negative 4 divided by 0, if I put negative 4 divided by 0 on my calculator says error. It's undefined. You can't divide by 0. So to find out what x cannot equal, what are the restrictions on x, we solve. We have to get the 4 to the other side and the 2 to the other side. The question is, which one do I take over to the other side first, solving for x? You always take the add and subtract to the other side first. So I am going to do the opposite of adding 2. I'm going to subtract 2 to both sides. 2 minus 2 is 0. I'm left with 4x cannot equal negative 2. Now I'm going to divide both sides by 4. I need to get the 4 over. It's multiplying. The only way to get rid of it is to divide by 4. So I'm going to divide both sides by 4. Four divided by 4 is 1x. Another way of writing 1x is just x. X cannot equal negative 2 over 4. And this is a fraction. We're going to reduce it. They both divide by 2. So the real answer that I would be looking for if this is a multiple choice test is x cannot equal 1/2. A negative, by the way, negative 2 over 4 reduces to a negative 1/2. So this is the answer to the first one. And by the way, these are in no particular order according to the test. I just went through this and found problems that are similar. So I'm looking at number 3. Number 3 says reduce the following expression to its lowest terms. So we're just going to cancel stuff out here. And 15 and 12, if you look at that, they both divide by 3. So when you reduce a fraction, you divide the top and bottom by the same number. We're going to divide the top and bottom by 3. 15 divided by 3 is 5, and 12 divided by 3 is 4. Do you see how that just reduces? Now, when we do fractions with powers, x squared is the same thing as saying x times x on top. Y squared is y times y. On the bottom, I have an x, and I have y to the 4th, y times y times y times y. If you look, 1x cancels, 1y cancels, 1y cancels, and I'm just left with an x on top and 2 y's on the bottom. In other words, y times y is y squared. Do you see, if I have 2 x's up here and 1 x, when I cancel out 1, I'm left with 1 x on top. Here I have 2 on top and 4 on the bottom. 2 cancels out, and there's still left 2 on the bottom. So this is my final answer, 5x on top and 4y squared on the bottom. That's reducing the rational expression. There's no adding or subtracting or anything. You're just reducing everything. All right. So, oh, I'm also going to do number 4 on this page. And this says the same thing, reduce. If you look at the previous problem, there's no adding and subtracting. Here we have adding and subtracting. So when I reduce this problem, the first thing, and for all these problems that we're about to do, the first thing you always try to do is factor. If we have terms like this, you always try to factor. And do you see how a 4 factors out of the top? I can divide that each term by 4. So the top then becomes 4 times y minus 16. Oh, not y minus 16. Y minus 4. Do you see? I divide this by 4 and I divide this by 4 and I get y minus 4. If I distribute back into it 4y minus 16. So I factor the top. The bottom does not factor 4 minus y. Okay, so this is y minus 4 at the top, and the bottom is 4 minus y. So I can't cancel those out. They're different. One has a positive y, the other one has a negative y. However, if you have this situation, what you can do is factor out a negative 1. So on the bottom, if I divide the bottom, watch, the bottom is 4 minus y. If I factor out, if I divide each by negative 1, 4 divided by negative 1 is a negative 4. Negative y divided by a negative 1, negative divided by negative is a positive. Do you see? I just factored out a negative 1. When you divide, that means you factor out. And I end up with a positive y now and a negative 4. The same as the top. I have a positive y and a negative 4. So, and by the way, I can change this to a positive y minus 4. I can put the y first. It's still positive y and a negative 4. So on the bottom, I'm going to do this, negative 1 and positive y minus 4. Do you see now the parentheses can cancel because they're identical, and I end up with 4 minus 1, 4 divided by a negative 1, which is a negative 4, and that's my answer for this problem. So if you see y minus 4 or 4 minus y in the parentheses, they're exactly the same, they're opposite signs. Just factor a negative 1 out of one of those expressions, and you'll be able to cancel that out. So once again, there's about 12 questions on the test. I should be covering very close to 12 problems because these are very similar to the problems on the test. All right. Let's see where I'm at now. I thought I was here. Okay, let me see where I'm at. I got to go to the previous page. This is the next one I wanted to do. Find the restricted value. If there are no restrictions, indicate no restrictions. So I need to find the restricted value. Once again, when we're looking for the restricted value, when we have a fraction, the only thing we're looking for is the bottom cannot equal 0. I don't care about the top when I'm looking for restricted values for rational equations. I'm only looking at the bottom. X squared minus 3x minus 10, that bottom cannot equal 0. So I'm going to factor this out. If you look at 3 terms when there's a 1 in front of x squared, this factors to 1 times 10 or 2 times 5. 2 times 5 will get me a 3 if I do a minus 3 and a plus 2. Do you see? So my factors are a plus 2 and a minus 3 with an x and an x. So you do have to know how to factor at this point. So that's what we end up. This is the correct factoring. Wait, that's not a 3. That's a 5. Thank you. I can't read my own writing. That's a 5. A plus 2 and a minus 5. Do you see this equals positive 2x? This equals a negative 5x. When you combine those, you get a negative 3. When you multiply these two, you get a negative 10. So now I have x plus 2 times x minus 5 cannot equal 0. So using the 0 multiply rule, x plus 2, it cannot equal 0, or x minus 5 cannot equal 0. Because if this is 0, then the bottom becomes 0. If this is 0, then the bottom becomes 0. Those are restricted values. So I just get the 2 to the other side by subtracting 2 to both sides. And my first restriction is x cannot equal a negative 2. The other restriction, I got to get 5 to the other side. It's a minus 5. So to get it to the other side, I'm going to add 5 to both sides. And x cannot equal 5. So the two answers are x cannot equal negative 2 or 5. Those are the restrictions. Because if I put negative 2 or 5 into this problem for the x's, the bottom becomes 0. Let's try to put 5 in there really quick. 5 squared is 25. Negative 3 times 5 is negative 15 minus 10. Do you see? 25 minus 15 is 10. 10 minus 10 is 0. If I put a 5 in there, I get 0. Also, if I put a negative 2 in there, I also get 0. These are the two things that will make the bottom equal 0, negative 2 and 5. All right. Moving on. So I'm going to do problem number 6 here on page 90 of the workbook. Problem number 6. So it says perform the indicated operation. The indicated operation is multiplication, right? We're going to multiply. The way to do this, step 1, you factor everything. All we're doing is step 1, factoring. Step 2, cancel. That's it. We're going to factor and then we're going to cancel. So I'm going to factor the top. I'm going to factor this part here. You might have to use the AC method to factor that. I don't want to go through. I'll do one. Let me do this AC method to factor this. 2x squared plus x minus 3. You can use the AC method or trial and error, whatever you take. The AC method, this is A and this is C, is 2 times 3 is, AC method is 6. Find all the pair that multiply together, get 6. 1 times 6 and 2 times 3. How do I get a plus 1 in the middle? If I do a plus 3 and a minus 2, that gives me a positive 1. So this factors to a negative 2x and a plus 3x. Do you see? Negative 2x plus 3x still give me a positive 1x. Then I bring down my 2x squared and my minus 3. And factoring using the AC method, now I have 4 terms, so I have to factor this by grouping. Group the first 2, group the second 2, make sure there's a plus sign between them. Find the GCF out of each group. Do you see each can be divided by 2 and each can be divided by x? So I'm going to divide each of these by 2x so 2x in the first parenthesis. I'm going to divide this by 2x and this by 2x. The 2's cancel. X squared over x is x. 2x divided by 2x is just 1. Here, the second one, I'm going to divide each by 3. I'm going to factor out a 3. 3 divided by 3 is x, and negative 3 divided by 3 is negative 1. Do you see when you use the AC method and you're factoring 4 terms after this, the parentheses must be identical. They are. So I factor out the parentheses. I take the parentheses out of here. The parentheses is x minus 1. I'm getting a little messy, sorry. X minus 1. When I factor out the parentheses, whatever's left over goes in the second parenthesis. So this and this factor out. I'm left with 2x and a plus 3. So this factored, this right here, all that work was just for factoring that. I'm left with x minus 1 and 2x plus 3. On the bottom, if you notice, I can factor an x out of there only. So I factor out an x, and if I divide an x out, I'm left with x plus 4. Then multiply. If I factor here, I can factor a 2 out of there. If I divide each of those by 2 on top, 2 divided by 2 is 1x, and 8 divided by 2 is 4. And on the bottom, x minus 1 doesn't factor. So step 1, this whole problem, factor everything, we've done it. The only thing left is to cancel anything on the top and bottom that's the same. Do you see how the x plus 4s cancel? We have one on top and one on the bottom. And the x minus 1s cancel, one on the top and one on the bottom. We are left with 2x plus 3 on top. We also have a 2 on top. I always like to put the numbers out in front. On the bottom, the only thing that's left is an x. So that's all we do. We factor everything, and then we cancel. My answer is 2 times 2x plus 3 over x. Don't multiply it to get back together. Your answer will always be in the factored form. All right. So I'm also going to do problem 7 and 8. So I'm going to go ahead and erase this now and do problem 7 and 8. Great thing about these videos is you can go backwards and rewind and hit pause. So the next problem, number 7. Oh, by the way, if you look, my answer was a little different than what they gave. They multiplied that 2 back in. Normally you don't do that. You leave it in the factored form, but you can take a look at your answers. If you're fully factored and they multiply that 2 back in, just multiply it back in and pick that answer. Okay, problem 7. Don't forget, when you divide fractions, you leave the first fraction alone. You change the divide sign to multiply, and then you flip the second fraction. X squared plus x over 2x minus 2. Keep the first fraction, change the divide sign to multiply, and then flip the second fraction. So now we're going to just use our rules. Step 1, factor everything you can. And step 2, cancel. So nothing factors on the top of the first fraction, but a 6 factors out of the bottom. Do you see how I can factor a 6 out of there? On the top of this one, an x factors out of there. If I divide both of those by x, I'm left with x plus 1. And on the bottom, a 2 factors out, and I'm left with that. Okay, so we factored everything out. Now let's cancel. X minus 1 cancels with x minus 1. A top and a bottom, if they're the same, will cancel. X plus 1 cancels with x plus 1. So what's left on top when I multiply these fractions together is just an x. And on the bottom, I have 6 times 2. 6 times 2 is 12. And there's my answer. So simplify these or do the indicated operation. If it's a divide, The only thing you do is flip that second fraction and change it to multiply, factor everything out, and then cancel. So we're going to do the same thing for problem number 8. And once again, each one of these problems that I'm doing is really similar to a problem that's on the test. All right, so problem number 8. Let me erase the one above it. Gives me a little room. Problem number 8 says it's a divide, so we're going to rewrite it. The first fraction stays exactly as it is. Change the divide sign to multiply and flip the second fraction. So the x squared plus x minus 2 is on top, and the x plus 2 is on the bottom. Now we're going to factor everything we can. The top of this first fraction stays the same. The bottom factors to x, and 4 and 1, a negative 1. So make sure you know how to factor that. I'm factoring it. I don't show you all the factoring. I mean, we should have learned that last test. So you do have to know how to factor. This top one factors to x times x, and 2 and 1. Since we have a positive x, this should be a positive 1 and a negative 2. And the bottom factors to x plus 2. So we factored everything we can. Now look at any top with any bottom. I have an x minus 1 with an x minus 1. One top and one bottom. You can only do this when they're multiplying. That's why we had to flip it when it was divide. I also have an x plus 2 that cancels the x plus 2. So my answer is whatever's left over. An x plus 3 on top, and an x plus 4 on the bottom. There's my answer. Now, just to warn you, I see some people trying to cancel out these x's. Do not do that. When you have two terms with a plus sign between them, you can't cancel out the x's because the x plus 3 is a group. See, that's why we're able to cancel these groups. They're groups. And if you have more than one group, you have to have each one in parentheses. I don't have the bottom, this answer in parentheses because there's only one group on top and one group on the bottom. So you don't need parentheses, but you can. If you wanted to, you can only cancel the entire group at a time. You can't cancel the x's individually. You can only cancel x's individually if they're not being added or subtracted. Do you see if I had 3x divided by 4x, there's no add or subtracts between these, and the x's just cancel. You can only do that when it's multiplying. If there's an add or subtract on the x, you have to put it as a group, and the whole thing has to cancel at once or nothing at all. All right, I'm just going through, trying to find some more problems. I'm going to page 93. Mm-hmm. 93, number 4. So once again, this is very similar to something that's on the test. It's a divide problem, so we are going to just rewrite it. 5 over m plus 4 squared. Change it to divide, changes to multiply, and then we flip the second fraction, m squared minus 16 over 10. Okay, so now that we've changed it to a multiply, we factor everything we can. Well, the first fraction actually doesn't factor. M plus 4 squared is really m plus 4 times m plus 4, right? 5 squared is 5 times 5. 9 squared is 9 times 9. m plus 4 squared is m plus 4 times m plus 4. This top factors, when you factor two terms, m squared minus 16, you try to square the first term, which is just m, and you put something in parentheses to square it to equal the second term, which is 4. You can only do this if there's a negative, a minus between it. So this ends up factoring to m and m, 4 and 4, and then always a plus and a minus when you factor two terms like this. So this factors to m plus 4 times m minus 4 over 10. So we factored everything we can. The only other step left is to cancel any top and bottom. N plus 4 cancels with m plus 4. By the way, 5 goes into 5 one time, 5 goes into 10 two times. Do you see the 5 and the 10 reduces? So on top, I'm left with 1 times m plus 4, 1 times m minus 4, which is just m minus 4. And I'm on the bottom, 2 times m plus 4. 2 times m plus 4. And there's my answer. They may, I hope not, but they may make you distribute this like that other problem did, 2m plus 8. So either one of these are correct. Hopefully they don't make you. Normally they leave it in factor form. Allergies are really bad today. A lot of oak. And I got this huge oak tree in my backyard. 96. Let's see. Page 96. Number 6. State any restrictions on x and then solve it. So we're going to state the restrictions first. Remember, restrictions for rational equations, the bottom cannot equal 0. Well, look at the bottom of these. Are there any x's? No, the bottom can never equal 0 here because there's a 4 there. There's a 2 here and there's a 16. There are no x's, so x can never, no matter what you plug into x, it can never make the bottom equal 0. So for this problem, since there's nothing on the bottom, no x's on the bottom, there are no restrictions. There are no restrictions for this problem. So now to solve it, we're trying to find out what x equals. I'm going to erase this now. When you have a rational equation like this, and there are no restrictions to the bottom, and we're solving for x, if you notice, we're doing something different from the last problem. The last problem didn't have an equal sign. We weren't trying to find x. We were just multiplying, we were factoring and canceling, and that was it. Now there's an equal sign in the problem. We're trying to find x. So what you do first when you're solving a rational equation is multiply everything by the LCD, the least common denominator. What is the common denominator between 4, 2, and 16, the least common denominator? The way to find that is just start multiplying the numbers. 16 times 1 is 16. 16 times 2 is 32. 16 times 3 is 48. And then do it for the next higher number. 4 times 1, 4 times 2, 4 times 3, 4 times 4, 4 times 5. And then the next number, 2 times 1, 2 times 2, 2 times 3. If you notice, the first number that appears in all three is 16. 16 is my LCD. So step 1, you find the LCD. Step 2, multiply each term by the LCD. So I'm going to multiply each of these terms by 16. I'm going to multiply this first term by 16. I'm going to multiply this term by 16 and this term by 16. 4 goes into 16 4 times. So you see there's nothing left on the bottom, but on top I have 4 times 5, which is 20x. Here, 2 goes into 16 8 times, so on top I have 1 times 8. So this is a minus 1 times 8, which is 8. 16 divided by 16 is 1, so I just have equals a negative 3 times 1, which is a negative 3. So now I'm just solving for x. I need to get the 20 to the other side and the 8 to the other side. You always take the add and subtract to the other side first. So I'm going to, instead of minus 8, I'm going to add 8 to both sides. I'm left with 20x equals 5. Negative 3 plus 8 is 5. Then I'm going to divide both sides by 20. Get the 20 to the other side. And I'm going to divide by 20. $20 divided by 20 is 1x. Another way of writing 1x is just x. 5 divided by 20 reduces. They both divide by 5. And I get 5 divided by 5 is 1, and 20 divided by 5 is 4. So the answer is x equals 1/4. All right. Have you been keeping track on how many problems I've done so far? I'm looking for more. I'm on page 99. I already have them marked, so I know which ones I want to do. Once again, the problems I do are very similar to the ones on the test. So I'm going down to problem number 2 on page 99. So first thing says state the restrictions. So the restrictions are the bottom cannot equal 0. Do you see we have x's? In other words, 4x cannot equal 0. Here, there's no x, so I'm not worried about that bottom. I'm worried about this bottom, though. 9x. It cannot equal 0. The bottoms cannot equal 0. Well, solving for x, I get the 4 to the other side. It's 4 times x, so I'm going to divide both sides by 4. 4 divided by 4 is 1x. And 0 divided by 4 is 0. Same here. When you divide by 9, 0 divided by 9 is 0. So the restriction is x cannot equal 0. Because if I put a 0 into the x, this bottom is 0, and 3 divided by 0 is undefined. So you cannot have 0 as an x. That's the only number that will make the bottom or make this fraction undefined. That's the restriction. Okay, so now we're going to solve. So we know the restriction is x cannot equal 0. That's our restriction. And I'm going to add it down in here. X cannot equal 0. Now we're going to solve for x. Now we're solving. We're trying to find x. And we're going to do the same method we did in the last problem. Find the LCD between all the bottoms. We have 4x, we have 9, and we have 9x. Well, the only numbers I have in 4 and 9, 9 times, I'm going to go through 9. 9 times 1 is 9, times 2 is 18, times 3 is 27, times 4 is 36. Do you see 4 times 1, 4 times 2, 3, 4, 5, 6, 7, 8, 9. 36 is the first number that pops up. The LCD is 36, but there's an X. You always use the highest power X as your LCD. If there was an X and an X square, the LCD would have an X square in it. So you always use the highest power X for your LCD. So my LCD is 36X. That's what I'm going to multiply each term by. So I'm going to multiply, let me change my color. I'm going to multiply this times 36X. I'm going to multiply this times 36X and multiply this fraction by 36X. Do you see the X's cancel? And 4 goes into 36 9 times. I'm left with 9 times 3, which is 27. There's nothing left on the bottom. 9 goes into 36 4 times, so I have 4x times 2, which is 8x. And here the x's cancel, and 3, wait, that's not right. I multiply by 36x. I put 3x, 36x. The x's cancel, and 9 goes into 36 4 times. 2 times 4, what's left over is 8. Okay, so this is what we end up with. I need to get isolate x. I need to get the 27 over to the side of the other side and the negative 8. First, you take the add and subtract, so I'm going to subtract. It's a positive 27, so I'm going to subtract 27. So I'm left with negative 8x equals 8 minus 27. Which is a negative 19. I'm now going to divide by negative 8. Divide by negative 8. The negative 8's cancel, and I'm left with x equals negative divided by a negative is a positive 19 over 8. Don't use a decimal answer. Keep it as a fraction. It doesn't reduce, so we're done. And that looks like the test to me. I'm trying to count how many I actually did. 3, 4, 5, 6, 7, 8, 9, 10. So it looks like I did 10 problems, but there are 12 on the test, so some are really similar. So this is pretty much the test. I just did 10 of them, and there's 12 questions on the test. I hope this helps. Let me know if it helps. You guys have a good day, study, and then take your test. We'll see you.